This is Algebra 1, Lesson 1. For this lesson, you're going to need a handout that looks like this and a glue stick. So we are going to talk about classifying real numbers. So if you'll just write Lesson 1, and you can use L for lesson. Number 1, you need to be at the top of your page in your notebook. Classifying real numbers. And you can use shorthand. This little pound sign means number, and then with the S means numbers. So we're going to start with what a set is. A set, that's a vocab word, is a collection of objects. So if we are naming a set, we use braces. And that just means you have to have a brace at the beginning of your list and a brace at the end of your list. So there's 3 types of sets that we want to go over. The first one's the null or empty set. So if you don't have anything at all in it, it's called the null set. The way we write that is we just write our braces with nothing in them. That shows that that's the empty set. Or we can use a 0 with a line through it, which stands for the null set. Both of these stand for the null or empty set. We can have a finite set, which means that we'll have braces, we'll have objects inside of the braces, and they are end. So just, for instance, this is an example where it only has 2 items in this set. Then we have what's called an infinite set. In the infinite set, we're going to need to use ellipses. So let's say we're counting by tens. So 0, 10, 20, 30. Well, we could keep counting by tens, and we don't want to write all of them because that would be impossible. So we're going to put 3 dots. Now those 3 dots are just called ellipses. Okay, so the 3 dots are ellipses. And that just means it's going to continue on without end. Now we're going to glue the real number system in our notes, but let's glue it at the end. Okay, so right now I want you to put in here natural numbers, and natural numbers are like counting. So if I said to you, count to 10, you're going to start with 1, and you're going to go to 2, 3, and we'll put ellipses to show that you're going to continue to count. Now whole numbers has all of the natural numbers, but it also has the number 0. I like to think of the number 0 looks like a hole in the ground. It's a different kind of hole, but this is called a whole number. So 0 plus all the natural numbers. See how the natural numbers are inside this box of whole numbers. So those all are included. Now integers are all the natural numbers and all the whole numbers. See how they're inside the integer box. But then you have to add the negative numbers. So it's going to continue down the negative numbers, and then we'll have -3, -2, -1. Then we have what's called rational numbers. And these are numbers that can be written as fractions using integers. So rational numbers include all of these boxes: integers, whole numbers, natural numbers. So here's some examples. 1/2. Any repeating decimal is also a rational number because you can write that as a fraction. -2/3. Any decimal number that ends is, that's truncated, wait, what do you call that? It has an end to it, is also rational. Now in the real number system, we also have what's called irrational numbers. These are numbers that can not be written as a ratio of 2 integers. So if it's in decimal form, irrational numbers do not repeat or terminate, which means ends. So here's an example: the cubed root of 5. That's an irrational number, and it is a number. we have the square root of 2, the negative square root of 2. We have pi as an example, 3 root 3, 3 pi, etc. So there's quite a few irrational numbers, and these are actually numbers. You don't want to be scared of them. Okay, so closure just means that if you take any two numbers out of a set and you perform an operation that's called under a given operation, it's going to give you another number that's in the set. So we're going to write a definition that says if you take two numbers within a given set, and it's going to be under a given operation. So we have 4 operations: multiplication, division, subtraction, addition. So it's under a given operation. So after you perform the operation, it will give a solution in that given set. I'm going to put which is found in that given set. So that's the definition of closure. Another, see, that's our vocab word. We also have counterexample. That's a vocab word. Counterexample is just an example that proves a statement false. Okay, so we are going to do some examples using closure and counter example. So are whole numbers closed under addition? If the answer is no, we're going to want a counterexample. So I'll put the counterexample after we put the answer. We're going to have more than one example here. Are whole numbers closed under addition? So let's look at whole numbers. They start with 0 and they're the counting numbers. So if you take two of those numbers, any two of those numbers, and add them together, do you get an answer that is also a whole number? Yes, you do, and all the time you do. How about subtraction? So are whole numbers closed under subtraction? So these little dots here are called ditto marks. You guys probably already know that. That just means I don't want to rewrite the word. So is it closed under subtraction? So if I take any two whole numbers and subtract them, am I going to get a whole number? What if it was 3 minus 5? Is the answer a whole number? No. So 3 minus 5 equals -2, and -2 is not a whole number. So this is a counterexample. Just shows that that is a false statement. Now we have another vocab word, intersection of two sets. Well, how about of just sets? It doesn't have to be two sets. So the intersection, and we're going to call them two sets A and B. That is just what the sets A and B share in common. Now we're going to have some examples of intersections and unions here in a minute. So here's set A, here's set B. The intersection is anything that falls in both sets. Then we have the definition union of sets 2A and B. I forgot to tell you the intersection, if you're going to name the intersection of A and B, you put a little, like a hump between them. So A intersect B is what they have in common. So the union of A and B, you put with the little capital U in between them. A union B. It's basically all the elements that are in A or B. So here's our set A, here's our set B. It's all of these elements. Now the elements that they share in common, you don't have to write twice. Okay, we're going to do, oh goodness, I haven't scooted this up. There you go. Okay, I'm going to give you some examples of unions and intersections. So the first set A has the numbers 2, 4, 6, 8, 10, 12. And our set B is 3, 6, 9, 12. Now this is just an example. We're going to show what A intersect B is. This is the set of numbers that is in both lists. So we have a 6 is common and a 12. They both have a 6 and they both have a 12. So that's the intersection. Now when we do the union, it's all the numbers listed, but you only list them once. So we're going to go 2, 3, 4, because there's a 3 over here. Then comes 6, 8, 9, 10, 12. That's the union. It shows every single one of those elements listed one time. And that's the end of our lesson.